Yeah, welcome students. I am really happy to present this uh, network problem here, the project network. That's what is coming here. And let me take one problem. Okay, this is the problem given to us. Okay, draw network and critical path for the given particular problem, where there are 1 2 3 4 5 activities are there, represented by 1 to 2, 1 to 3, 2 to 4, 3 to 4, 4 to 5, and the corresponding time taken also given. A takes 2 years, B takes 5 years, the activity D takes 1 year, and the activity C takes 3 years, and the activity E takes 2 years. And this is the logical connection given to us. Okay, so under this logical connections, we have to draw the picture according to this, where the events are should be given as 1 2 3 4 5, like that. So we have to draw that. The critical path also we have to find out. Let me do now. I am drawing the event like this. Okay, right. Now last event is this. Then I am dividing that into two halves. The upper halves to denote the event number, and lower half will denote the earliest time and latest time. Now look at that. 1 to 2. So 1 I am writing here, 2 I am writing here, 1 to 3 comes, so I can write 3 here. Then 3 to 4 comes, 2 to 4 comes, so 4 should come here, and 5 should come here. Okay, so very good, very good. Now this I am dividing into two halves. The down half I am dividing into two halves in order to write the earliest time and latest time. Without earliest time and latest time, we cannot find the critical path. Now look at that. 1 to 2, one error, and this is what is given here. Activity A is given, and then another activity 1 to 3. What is the name of the activity is given as B. Now the condition given here, A should be less than D, B should be less than C. Less than means B should be finished, after that only C should start. Here A is less than D means A should be finished, then only D should start. Here this is the meaning that E can be start if D and C should be closed. Okay, should be closed means should be finished. So with that condition, we have to draw the picture here. So what will come here? 1 2 3, 2 to 4, 2 to 4. The activity is what? D. Now look at that. A should be finished, then only D should start. A should be finished, then only D should start. Now B should to be finished, then only B should be finished, then only C should start. So C must come here. Okay, yes. Then afterwards D and C must be finished, then only E should start. E should start. Okay, so E. So now all the conditions, the logical sequence are satisfying here, and the activities nodes also satisfying every conditions. Okay, now what are the time taken, corresponding time taken? We have to write side by side. Am I correct? Activity A takes 2 years, activity B takes 5 years, activity C takes 3 years, activity D takes 1 year, and activity E takes 2 years. Okay, so let us check up that. A takes 2 years, B takes 5 years, D takes 1 year, and C takes 3 years, and E takes 2 years. Okay, now what is the next calculation? The next calculation is about earlier calculations. I mean, at earliest time, latest time. This is called earliest time, and this is called latest time. So that will calculate now. So I am starting with 0 here. 0 plus 2, 2. 0 plus 5, 5. Now since only one arrow ending here, for forward pass only one earliest time will come there, but here in this particular event 4, there are two arrows are ending here, therefore we have to calculate earliest time for this event by either way, and which is maximum we have to write. Now let us take this event. 2 plus 1 3, 5 plus 3 8 comes. 2 plus 1 only 3, but 5 plus 3 8 comes, so 8 we have to write here. For forward pass we have to take maximum. For backward pass we have to take minimum. Okay, this is very important. Now look at this. So only one arrow, no problem. 8 plus 2 10 will come here. Okay, 10. So this earliest time becomes the latest time, so 10 years. 10 minus 2 8. Okay, here only one arrow coming here. 8 minus 3 5. Here 8 minus 1 7. But when you come here, there are two arrows are going back to this particular event. So for that backward calculations, minimum we have to take. So calculate the latest time either path and takes the minimum. 7 minus 2 5 will come. 5 minus 5 0 will come. So which is the minimum? 0 is a minimum. Okay, right. Now we have to note that in which are the events which have the earliest time and latest times are equal. Which are the events where earliest time latest time must be equal. But here earliest time latest time not equal. But here earliest time latest time equal, earliest time latest time equal, earliest time latest time equal, and earliest time latest time equal. Through this we are drawing a path. Through this we are drawing a path. Okay, now look at that double line path. Okay, this path is called a critical path. Remember, a critical path is one which passes through the events where the earliest time and latest times are equal. That path is called a critical path. Okay, so in this particular problem, 1 first event, 2 third event, 2 fourth event, and last one is fifth event. This is what a critical path we say. Why we say? Because the earliest time and latest time of the events lying on the path are equal. Here 0 0, 5 5, 8 8, 10 10. This path is called what? Critical path. Okay, so critical path we say critical path. Now what is the time taken through critical path? That also very important. Am I correct? Time taken through critical path. Time taken through critical path. Okay, time taken through critical path. Here from 1 to 3 5 years, plus 3 to 4 3 years, plus 4 to 5 2 years. So total comes 10 years. So 10 years is the time taken through critical path. At project time we can say the project time for this particular project given by A, B, C, D, E activities which are taking the corresponding time 2, 5, 1, 3, 2. Then the critical path is 1 to 3, 3 to 4, 4 to 5, and the time taken through critical path is 10 years. Okay, so that's all the problem. Okay, so this is a way we have to do the problem. Thank you.